Now, in this question, we are going to say what is the Thevenin equivalent voltage associated with resistor R1, right? This is a FE style question, and you possibly could come on PE too. PE, electrical and computer, electronics, controls, and communication. It's possible could come, but this, say we focus on it as a FE style question. So what is the Thevenin equivalent voltage associated with resistor R1? And of course, on the exam, and the FE exam, you'll get 4 choices to choose one, right? In the circuit, an ideal voltage source and an ideal current source are combined with 3 resistors. You see the ideal sources, the voltage source ideal and a current source ideal. I started to show you here that right away you could see is associated with R1, the equivalent voltage associated with R1. So we could consider R1 to be a load, right? A load resistor. So if we consider R1 to be a load resistor, which is 8 ohm resistor, we're going to isolate it. We're going to isolate it, which means we're going to treat it as a load resistor, right? And we're going to work out the Thevenin equivalent as it's seen looking inside through the eyes across this resistor here. Actually, it's going to be across R2, this resistor here, because this and this is the same point. So how do we proceed? First and foremost, we're going to find R-Thev, right? Because they want us to find the equivalent Thevenin voltage. So we're going to proceed first by finding R-Thev. How do we find R-Thev? Remember the rule of finding R-Thev. We're going to short circuit our voltage sources. Have to be short circuited, and our current source is going to be open circuited. So let's do that. Let's short circuit the voltage source. And if you short circuit the voltage source, it's going to be one piece of wire, right? And then it's going to be this resistor R2 here that's standing. And then, of course, this resistor R3 will remain here, right? So the current source will be open circuited there, so will be there nothing here in the current source. We took out the current source, it's going to be open circuited there. And as we say, we're going to isolate the circuit. We're looking in here to find R-Thev, right? Based on looking at it on that side and removing the 8 ohm resistor, which is considered a load. R1 is considered a load resistor at this point. So right here, based on looking on it this way, inside it this way, we could calculate R-Thev, right? Well, what is R-Thev here? It's actually, if you look at it properly, you'll see that R-Thev is actually 2 resistors in parallel, isn't it? It's actually 2 resistors in parallel. That's all it is. These 2 resistors are actually in parallel. So in that case, R-Thev is going to be equal to product over sum then. Is R2 multiplied by R3 over R2 plus R3, right? So in that case, we have R2. What is R2 value? The value of R2 is 6 ohms. 6 ohms. And the value of R3 is actually 4 ohms. Over sum, which is 6 plus 4, 10. Note, we could also do it like the inverse of the resistance and then do that to find the total resistance, right? But it's easier to do product over sum in this case. And so this is going to work out to be 6 fours 24 over 10, which works out to be 2.4 ohm. So that's the resistance. Note, that's the resistance of the circuit, right? That's the resistance. That's the R-Thev resistance of the circuit. But they're asking you for V-Thev. So how do we proceed to find V-Thev? Well, guess what we're going to do? To find V-Thev, we're going to have to put back the voltage in the circuit, right? The sources in the circuit, and do a loop analysis, right? So in this case, if we do that, we could redraw the circuit. We could redraw the circuit here, right? And this is 28 volts. This is R2, which is 6 ohms. And this is R3, which is equal to 4 ohms. And again, current source, right? So we redraw the circuit and solve the loop. That's all it is, right? Well, if you solve this loop, what you're going to realize is that this is I2 and this is I1, right? So minus 28 volts plus 6 ohms times I2, which is the current through this loop, and then plus, but look at R3, it's surrounded by 2 currents, and one current is besides going in opposite direction to our direction, to our clockwise flow, so we're going to treat that as a negative current. So that means this is 4 ohm, right? This resistor is 4 ohms, right? So that means 4 ohms times I2 minus, what's the current here? 6 amps, right? Which is I1. So minus becomes 6 amps plus 6 amps. And that's going to be equal to 0, correct? So minus 28 plus 6I2 plus 4I2 plus 24, 6 4 is 24 equals 0. So if you add all the I2s, that becomes 10I2, right? And then minus 28 plus 24 is actually 4, minus 4. Take it on the other side, it becomes 4. So I2 is equal to 2/5, which is equal to 0.4 amps. So 0.4 amps is actually the current flowing through I2 here. And this is, take note that when R1 going to be isolated as a load resistor. So in that case, we know I2, so we can find the voltage across this resistor R2, right? Since we know the current that's flowing through there. In that case, V2, call it V2, is going to be Vthev. Since it is the voltage across the the point where R1, which is the load resistor, is missing, is removed. So Vthev then is going to be the same thing as V2, right? When the load is removed. Load resistance R1 is removed. So Vthev is equal to what? I2 times R2. In that case, it is I2, which is what? I2 is 0.4 amps times R2, which is 6 ohms. So 6.4 times 6 is 2.4 volts. So Vthev is equal to 2.4 volts.